Alright, complex numbers presented and narrated by Tristan H. for B-4 Algebra 2, but with the assistance of Darian G. and Gavin S. So, starting with our lesson objective, it's to understand complex numbers and be able to solve simple problems that use complex numbers. Now, this is just kind of the groundwork because complex numbers, as their name kind of implies, are pretty complex. So, starting out, we have to ask the question of what are complex numbers? Well, complex numbers are, as this example states, examples of imaginary numbers along with real numbers, a being a placeholder for any real number and bi being a placeholder for imaginary numbers and or pure imaginary numbers. Now, to understand that, you need a little bit of background information. So we're going to start with natural numbers. Now, natural numbers are numbers starting at 1 going to positive infinity in units of 1. So 1, 2, 3, 4, and so on and so forth. Whole numbers, which encompass natural numbers also, which you'll see will become a pattern here, are also in units of 1 to positive infinity, but they include the number 0. So it goes 0, 1, 2, 3, 4, and so on and so forth. Now integers are negative numbers, 0, and positive numbers. So it goes, the range is from negative infinity to positive infinity, but it's still in units of 1. So you get a -1, -2, -3, or 0, 1, 2, 3, 4. And it continues on for positive and negative infinity. Now rational numbers are any ratio of integers, or whole numbers or natural numbers, anything that falls within these circles, because rational numbers can be integers and whole numbers and natural numbers. However, natural numbers can't be whole numbers, or it's not that they can't, but there are some that aren't, like 0 is a whole number but not a natural number, and -1 is an integer but not a whole number, right? So with rational numbers, it's just a ratio of two integer numbers. So your 1 over 4, your -2 over 3, and so on. Now, real numbers are any number that can be represented on a number line or by an infinite decimal expansion. So an example would be if you have just a number line going from negative infinity to positive infinity, you can just take your right index finger or left, depending, and point anywhere, just anywhere on that number line, and say that is a real number. It counts. If it's able to be represented on a number line, it counts, right? And infinite decimal expansion, so example 0.33 repeating. It's infinitely repeating, infinitely expanding, but it's still a real number. Now, imaginary numbers, it's a complex number that can be written out as either multiplied or added to a real number. So the letter used to represent imaginary numbers is I. So as you can see here, a plus bi, which is the same as the complex number example, a plus bi. A is just any real number. B is a placeholder for whatever goes in front of I, and I is imaginary numbers. Now, imaginary numbers, there's multiple types. There's imaginary numbers, a plus bi being the example, or pure imaginary numbers, which, if you'll notice, are the components of imaginary numbers just separated. So bi, b being a placeholder for any other number you want to put there, and then or any real number, and then I being imaginary numbers. Now I won't change when it's written out like this. However, it's always going to represent imaginary numbers, and a just being any real number. So getting further into what complex numbers are, complex number is made up of two parts, a real number portion and an imaginary number portion. Now, a is any real number. It should be represented by any real number. And bi is the imaginary portion of this. B can also be any real number, but I is the imaginary number, and that changes. And we'll get into that a little bit later. But here's a good example. 3 plus 5i. 3 being a, 5 being b, and I, of course, being I representing imaginary numbers. Now 3 can be any imaginary number, or a can be any imaginary number. However, in this case, it's represented by 3. So this would be an example of a complex number because it has complex and imaginary number because it has both the components required for both a complex and imaginary number. Now, if you wanted a pure imaginary number, it would be something like 5i or bi, or whatever else you wanted to add with I to make an imaginary number. So this is just an example of an imaginary number. moving on, the pattern for finding the value of I is pretty consistent, and it's relatively easy to remember. So if we start out here, I to the first power equals I. Simple, right? 1 to the first power equals 1. But I to the first power equals I. Now I to the second power equals negative 1. And you'll see a pattern start to show up with negatives and positives here. I to the third power equals negative I. I to the fourth power equals positive 1. So when it comes to going from 1 to 3, you go from I to the first power equaling I to I to the third power equal negative I. And for the even powers, so second to fourth, so the second power goes from negative 1 to the fourth power being positive 1, and it alternates with every other one being the positive or negative version of the one that you're currently thinking about. So if we take I to the fifth power, we go to the other one, it is the same, just a negative or a positive, respectively. Now these are practice problems, just simple practice problems. For one, you have 1 plus 4i in parentheses minus negative 16 plus 9i. And for number 2, you have negative 3 minus I minus 6 minus 7i. I'll give you a second to solve these. Pause the video now if you want to go through them, and then we'll cover the answers. Alright, sounds good. So here's the practice problem answers. Now going through 1 first, you have 1 plus 4i in parentheses minus negative 16 plus 9i. Now, if you take the parentheses off and add this, or not add, but apply this negative appropriately, you would have 1 plus 4i, the same here because it's not affected by the negative symbol, plus 16 due to the double negative, because negative minus a negative number is positive, and then apply that to the negative, and positive makes negative. So you'd have 1 plus 4i plus 16 minus 9i. If you simplify that, that gets 17 minus 5i. Now, imaginary numbers, it's not like trying to solve for x. There's a different way to do this, but this is as far as you can go down here. Now for number 2, in parentheses, negative 3 minus I minus 6 minus 7i, you would do the exact same process, but you go through with negative 3 minus I, same as the first parentheses, minus 6 plus 7i, because positive 6 and a negative makes negative 6, and then negative and a negative makes a positive. You solve this out, you get negative 9 plus 6i, or 6i minus 9, depending on how you want to put it. So moving on, we get into complex numbers being even more complex with quadratic equations. Now this is a really useful graphic here. X equals 6 plus or minus square root of 36 minus 4 multiplied by 25 over 2. Just an application of the quadratic formula. Then you simplify it more and more. You solve it out. So 4 times, or negative 4 times 25, you get 100 at that point, and then that 36 subtracted from that, well, then you'd have 64. And the square root of something, you just ignore that minus, because square root of something, negative times negative, or positive times positive, is always going to be positive. So then you have 6 plus or minus 8i. Now this I gets added after the fact of doing the square root. So then you'd have 6 plus or minus 8i over 2. So then, separate it here and do 6 over 2 plus or minus 8i over 2. Now this goes out to 3 plus or minus 4i. Meaning your answers would then be x equals 3 plus 4i and x equals 3 minus 4i. It depends. Now, that's all we have for this lesson. However, go and practice. We have the note sheet, which covers all the things here. We have the practice problem sheet, which is great for what you need to do and to practice, because we have the homework due next class, which is the practice sheet, and the quiz next class for this, because the quiz is going to suck if you don't do your homework. So with that, do your homework. Stay in school.